All right, this one is for 4.5 functions. Another simple idea. We've been talking about ordered pairs. For example, we had stuff like 2 comma 3, 4 comma 5, 6 comma 7, and 8 comma 9. All right, so now what we're going to say is, look, when we give you a group of points like this, a group of ordered pairs, we want you to determine if this is a function or not. And basically what a function is it's going to be some type of graph on the coordinate plane. So in this case, we'd have 2 comma 3, which would be, for using color coding, 2 comma 3 would be 1, 2, up 3, 1, 2, 3, right here. 4 comma 5 would be 1, 2, 3, 4, up 5. 6 comma 7 would be, if that's 4, that's 5, that's 6, and then 7, 1, 2, 3, 4, 5, 6, 7. It's a line, it looks like. And then 8 comma 9, which would be 1, 2, 3, 4, 5, 6, 7, 8, and then up 9. I think that's right. Anyway, so if you plotted them, that's the shape it would make, right? And you can plot a line through those. You can see the line here. Okay, anyway, that's not what we're doing. What we're talking about is we're going to give you a set of ordered pairs, and it's your job to figure out if it creates a function, or the group creates a function or not. So here's my group. How do I determine if this is a function? It's very simple. The rule is, for every x, there can only be one y. Or, better yet said, every x, there can only be one x to one y. So what do I mean? Here, the x for 2 goes only to the point 3, right? So far, so good. There's no repeating x's. The x4 goes to the y value of 5. There are no repeating x's. The point 6 goes, not the point 6, but 6, which is an x, goes to the output 7, which means it's 1 to 1. And then finally 8 is attached or corresponds to an output of 9, which is only 1y. This does represent a function. So the answer is yes for this one. Now let me show you when it would not be a function, all right? Let me just change one thing for you. So here's what's not a function. I'm going to copy this, and let me show you down here what's not a function. Okay, so what's not a function would be if we had the same y values, and it really only applies to the x's, right? The x's are the thing that we're worried about. Let's say it was 2 comma 3, 4 comma 5, 6 comma 7, and watch this, 2 comma 9, all right? Now, we're going to check to see if we have a function. And in fact, we don't. Why don't we have a function? Well, here's the reason. Every y can only have one x. I should have said it that way the first time. 3 is attached to 2. 5 is attached to 4. 7 is attached to 6. 9 is attached to 2. If you take a look, we have one x going to 2 y's, and that's no good. If you really wanted to think about it, you can think of the x's conceptually. I guess for today, x's are like, they're like keys, right? Well, let's say they're like doors. Each door only has one key. That's what makes a good door, right? If a door has multiple keys that open it, it's a bad door. If it has this key and this key, well, we say that's a bad door. And so it does not work. It does not function. Not a function. That works for me, I guess. One door, one key, it functions. If one door has two keys, not a function. So we take a look. Here's the door number 2, door number 2. Door number 2 has 2 keys. It has 3 and it has 9. That's not a good door, therefore not a function. Let's try another one. So let's see if we can clean that up a bit. Let's say if it was 0, 2, 1, 3, 2, 4, 3, 4. The question is this a function or not? Is this group of ordered pairs a function or not? So basically, here's how you do it. First, you check to see if you have any repeating x's. I have a 0, I have a 1, I have a 2, I have a 3. It looks good, right? That means there are no repeating x's. Each door is by itself. That means it's good. So this is a function. And if you wrote it out like this, you would have 0 goes to 2, 1 goes to 3, 2 goes to 4, 3 goes to 4. Now here's what would make this not a function. Watch this. Let's say it was 0, 2, 1, 3, 2, 4, and 2, well, let's not do 2, 4 twice. Let's do, here we go, 1, 4. So now you have to check again. Check all your x's, your doors. There's a 0, there's a 1, there's a 2. There's another 1 here. There are 2 1s in the x position, right? There are 2, the door 1 has 2 different situations. So here's what I mean. Has 2 different keys. 0 goes to 2. The door 1 goes to 3. The door 2 goes to 4. But look, the door 1 goes also to key number 4. That's not good. The same door cannot have 2 different keys. That's a bad door. Now, the keys, if you can notice, can go to different doors, but we can't have it the other way around. All right? So plain and simple, a function, in a function, each x goes to exactly 1 y. If there is an x that goes to 2 different y's, let's say 3 and to 2, that is not a function. Not a function. And you would see it written like this. You would see like 1 goes to 3 and 1 goes to 4. That's not a function. 2 goes to 6. It also goes to 7. Not a function. They'd have to be by themselves. 1 would have to go to 3 only. 2 would have to go to 6 only. 5 would have to go to 7 only. Okay? Function, every x has exactly 1 y. Not a function, an x has more than 1 y.